Hi friends, thanks a lot to all my dear students and the subscribers also. We reach 1000 subscriber. Keep watching my channel and subscribe my channel and recommend your friend to subscribe this channel and keep watching this channel. Okay, now we are going to update about the Chandrayaan 3. Now the Chandrayaan 3 reaches in the last orbit, fifth orbit, to reach the surface of the moon then. Okay, now we are going to learn thermal phenomena. In one video chapter heat we learn the types of heat. Number one, sensible heat. Number two, latent heat. Number three, the radiant heat. Now what happens when heat energy is supplied to a body? When heat energy is supplied to a body, the temperature rises, rise of temperature, then expansion occurs, and then change of state of matter occurs. These are the three important effects of heat. Now how much heat will transfer from one body to the another body, that we learn today about the transfer of heat from one body to another. And when heat transfer, when the two bodies have different temperature, then the heat will transfer from one body to the another body, otherwise not. If the two bodies have the same temperature, no heat will transfer. That means let us consider the two bodies. Body A, this is body A having temperature T1 degree centigrade. Another body B, let this is be the temperature T2 degree centigrade. Okay, now if the two bodies, let T1 greater than T2, T1 greater than T2, so A is the hot body and B is the cold body. Now the body A touches to the body B, then what happened? Now they are brought in contact, then what happened? Then the heat will flow from the hot body A to the cold body B. Till the transfer of heat will occur, their temperature will be same. That means the temperature of the T1 gradually decreases and the temperature of the cold body T2 gradually rises, and this flow of heat will continue till the temperature will be same between A and B. But how much heat will transfer? That means when they establish thermal equilibrium, no heat will transfer from the hot body to the cold body. That means they are in thermal equilibrium. So this is the basic principle of calorimetry. And today we will learn this. That is the basic principle of calorimetry. Basic principle of calorimetry. Okay. Basic principle of calorimetry states that if the two bodies having different temperature are brought in contact, then the heat will flow from the hot body to the cold body. That means the temperature of the hot body decreases and the cold body temperature rises. The flow will continue till the temperature of the two body will be same. That means the heat released by the hot body must be equal with the heat gained by the cold body, but there are some conditions. So heat released by the hot body must be equal with the heat gain by the cold body. Heat gained by the cold body. Okay, let us consider H1 be the heat released by the hot body and H2 be the heat gained by the cold body, and H1 will be equal with the H2 only when these conditions are followed. In the basic principle of calorimetry. Number one, they should not react with each other. Two substances, two bodies A and B should not react. Number two, they should not make any solution. Because in case of the dissolution of a matter, either heat will produce or heat is released. And the third condition, no heat will exchange between the surrounding to the system or from the system to the surrounding. If these three conditions are followed, then H1 must be equal with the H2. This is basic principle of calorimetry. Mathematically, how can we represent this? Let's see. The mass of the body A let this is be hot body mass m1, and mass of the cold body, let this is be m2. M2 be the mass, and when the heat flow, then the final temperature will be, let final temperature, let this is be T degree centigrade, which is less than T1 degree centigrade but more than T2 degree centigrade. Now mathematically we can calculate this H1. This H1 equal, if the specific heat of the material A be S1, then M1 S1 into T1 minus T. And similarly, heat gained by the cold body H2 equal M2 S2, that is T minus T2. So they are same, since H1 equal H2, so we can write M1 S1 T1 minus T, this is equal M2 S2 T minus T2. From this we can calculate the final temperature of the mixture or the final temperature of the two bodies, make a thermal system. Okay, this is the basic principle of calorimetry, and this is the mathematical form, and these are the conditions also. Today up to this, for class 9 and 11 students, this is very important. Okay, up to this.